question 1 asks us to explain 4 variables that are needed for gas exchange to occur. Those 4 variables are pulmonary ventilation, alveolar gas exchange, circulatory transport, and systemic gas exchange. Going through those, we'll start with pulmonary ventilation. This is just breathing. And how breathing works is basically just a shift in pressures of different systems and the diffusion of oxygen and different gases down a pressure gradient. So gases love to travel from a high pressure grade or concentration to a low pressure concentration. This is important because when we breathe, what happens is that our diaphragm contracts and expands. When our diaphragm contracts, it expands and it also expands the lungs. So the volume of the lungs increases. When the volume of something increases, the pressure of within that something falls. So since the volume of the lungs increase and they expand, the volume within the lungs falls, and it falls just below, or the pressure of the lungs falls, and it falls just below the pressure of the atmosphere. So like all the air outside and around us, that at sea level would exert 760 torr or millimeters of mercury. And when we inhale, our diaphragm expands, the volume of our lungs gets bigger, and the pressure decreases to just below that 760 mark so that oxygen can flow from a higher pressure out in the atmosphere in towards the lower pressure area that is our lungs at the moment. And so that's how we intake the oxygen that we need. After we've taken it in, then we need the oxygen to go from our lungs to our blood. And that's where alveolar gas exchange comes from, because the oxygen goes into our lungs and into our alveoli. They contain the oxygen that we just breathed in, and capillaries will allow for a diffusion of that oxygen from the alveoli into the bloodstream. Same kind of thing is happening with pressure, except that just the unoxygenated pathways have and the unoxygenated the veins that hold unoxygenated blood have a lower pressure than the capillaries that they are getting the blood from. So oxygen will flow from the higher pressure gradient or concentration to the lower one and go into the unoxygenated blood through the capillaries to the arteries, which will hold the oxygenated blood. And in the arteries, or in the bloodstream, moving on a little bit to circulatory transport, we have these proteins called hemoglobin. And what hemoglobin does is it holds on to the oxygen. It's a part of the red blood cell, and it holds on to the oxygen so it can be carried for a time through the bloodstream and dropped off wherever it needs to go. And how it goes about getting dropped off is also through a change in pressure. So oxygenated blood has a higher pressure concentration than wherever it needs to go, to the muscles primarily, and it's going to flow down that concentration gradient from the high concentration in the arteries to the lower concentration in the muscle cells, and that's how oxygen gets from the blood to the muscles.